All right, hello folks. I'm continuing with the 2022 exam. So here's problem number 3. This is a very familiar problem type. They are giving us the graph of f prime and they're going to give us questions about f. Just one thing I will point out, sometimes the version they have is they will give you a graph like this and they'll say here's the graph of g, and then they'll say f is defined to be the definite integral from -2 to x of g of t dt or something like that. And then what you realize is that f prime is equal to g. So it's still the same fact that we have the graph of the derivative of something, but sometimes they present it a little more, not as directly. But let's look at this particular one. So they're giving us the graph of f prime. Right, they're making it very clear. Here's the graph of the derivative. They're labeling it as such. They're telling us that f of 4 is equal to 3. We'll presumably need that information. And the graph consists of a semicircle and 2 line segments as appears clear. So for part A, we're just finding f of 0 and f of 5. So maybe this isn't obvious, but you need to realize, okay, I'm going backwards from f prime to f, and I want a numerical answer. So let's use a definite integral. We almost certainly want to be taking a definite integral of f prime of x. But the question is, what are the limits of integration? Well, for this first part, I want to know what's going on at 0. And I'll notice that I do know what's going on at 4. So let's think about the definite integral from 0 to 4. On the one hand, the definite integral of f prime from 0 to 4, by the fundamental theorem of calculus, would be f of 4 minus f of 0. But on the other hand, we can actually compute this definite integral as a net signed area. So this would be -1/2 pi r squared, because we'll notice if we're just going from 0 to 4, then this area right here is a semicircle, and it's below the x-axis, so it's negative. The radius there would be 2. So that is the definite integral of f prime from 0 to 4. f of 4 is 3. So here we'll just move things around. So this is going to be -2 pi. So we have -3 minus 2 pi equals negative f of 0. And so f of 0 is 3 plus 2 pi. And we can do the same thing for 5. Oh, so this should have been in red, sorry. Right, so this is all answer. I'm trying to use red for my answers, what I would actually write down. If we do the same thing for 5, it's even easier. So the definite integral from 4 to 5 of f prime. On the one hand, that's f of 5 minus f of 4. On the other hand, that's just the area of a 1 by 1 rectangle. Right? They want that to be pretty easy, just 2 over 2 up. So that is 1/2 base times height, which is just 1/2. f of 4 is 3, so f of 5 is 3.5, or 7/2. So that's part A. You need that insight that, oh, a definite integral will allow me to get a numerical answer for f, and then you use the graph to find that. Okay, part B. Find the x-coordinates of all points of inflection for f. So we have f prime. I'm going to write what I know first. Let me make this bigger. Let's just repaste it. Okay, find the x-coordinates of all points of inflection for the graph of f. So, let's write what we know. F has a point of inflection when, and if I'm not 100% certain of this, let's just think about it. Point of inflection would be where f double prime switches signs. It's where f switches concavity, right? That's what we think of as the definition. So it's where f prime switches direction. So f prime switches from increasing to decreasing, or vice versa. So f has a point of inflection, we'll say where f prime switches from increasing to decreasing, or vice versa. That's just the general principle. Now let me go looking for where that happens. So decreasing, switching to increasing happens at x equals 2. Increase, 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 switching to decreasing happens at x equals 6. So this occurs at x equals 2 and x equals 6. Right, that would be worth 2 points on the AP. Basically, 2 points for getting those values correct. Sorry, 1 point for getting those values correct, and another point for fully explaining what it was you were looking at. All right, let's look at part C. So let g be the function defined by g of x equals f of x minus x. On what intervals, if any, is g decreasing? So g is decreasing if g prime is negative. G prime of x is f prime of x minus 1. So g is decreasing if g prime equals f prime of x minus 1 is negative, is less than 0. And that implies that f prime is less than 1. So let's just use our graph. Right? Where on this graph is f prime less than 1? We literally have a graph of f prime. So it is less than 1 starting at 0 until we get to 5. So this occurs on the interval from 0 to 5. I'm writing it with a closed interval, which is technically correct. If you made this an open interval, they do not take off for that kind of subtlety. Yeah, that's my understanding. Right, endpoints do not need to be included, but strictly speaking, it is decreasing on that entire interval. Okay, and finally, let's look at D. For the function g defined in part C, find the absolute minimum value on that interval. Did I copy this correctly? Okay, so let's just write this. The minimum will occur at an endpoint or a critical point. I'm just going to write that sentence to demonstrate my knowledge, and then let's use that to guide us forward. So our endpoints are x equals 0 and x equals 7. Our critical point would be where g prime of x, which is f prime of x minus 1, is equal to 0, which means f prime of x is equal to 1. We basically did this analysis already. And that occurs at 1 and 7. X equals 7 is already an endpoint. So basically, we have 3 things we want to figure out. I'm going to add a page here. We want to know the value of g at x equals 0. We want to know the value of g at x equals not 1, what did I put here? 5. At x equals 5. And the value of g at x equals 7. Now I'm going to do this a very formal way, and then we can say something else that will be easier. So g of x, let's just recall, is f of x minus x. So g of 0 is f of 0 minus 0. We've already computed f of 0. F of 0 we found is 3 plus 2 pi. G of 5 is f of 5 minus 5. We've already computed f of 5. Right? They're doing this intentionally. Right? They don't want you to have to do tons of extra computations. They're setting this up intentionally so that there's information you've already done. And then g of 7, this one we will need to do a little bit of work, is f of 7 minus 7. So let's just do a little bit of work on the side. The definite integral from 4 to 7 of f prime of x dx is f of 7 minus f of 4. But on the other hand, that definite integral from the graph, so this is a 2 by 2 rectangle, so this is area equals 1/2 times 2 times 2. This is a trapezoid with a base of 1 and an average height of 1.5. So this is 2 and this is 1.5. That whole thing is 3.5. So 3.5 is equal to f of 7 minus f of 4, which was 2. Right. When you're doing this, it'll actually be on pages next to each other. There won't be so much scrolling. Or f of 4, sorry. f of 4 is 3. So f of 7 is 6.5. And so here we have 6.5 minus 7, which is negative 0.5. So from all of that, we can see that this is our minimum at negative 1.5. And it says find the absolute minimum value. So we can say the absolute minimum value of g on this interval is negative 1.5. You can always do this technique. A minimum will occur at an endpoint or a critical point. So you can just find all of them and plug them in and see which is the minimum. For this problem, however, what we actually noticed in C, we learned that this function is decreasing from 0 to 5. And if you think about it, for the analysis we did, you would also know it is increasing from 5 to 7. So another way you could do this, making use of what we've already seen, right? So I'm just going to make this as a note because I have already solved this. But something you could note is you could say g is decreasing on the interval from 0 to 5 and increasing on the interval from 5 to 7. And it's a continuous function. So what you'd notice is if I have a continuous function that decreases until I get to 5 and then increases afterwards, that must be my absolute minimum. And then you can just plug in 5. So you'd still have to go back and figure out what that value is. But they actually set you up to already think about where is g decreasing and where is g increasing. And this is valid. If you have evidence that a function, it just does decreasing for a while, then increasing, then that critical point must be your absolute minimum, right? If all we have is an interval of decrease followed by an interval of increase, this is our absolute minimum. Similarly, you may have enough information to know that you have an interval of increase followed by an interval of decrease. That critical point must be your absolute maximum. But make sure you say what you're thinking. All right, let's do one more in this video. Okay, problem number 4, we have a table. So an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by of the function r. R is measured in centimeters, t is measured in days, and we have a table for r prime. Okay. So let's just do this piece by piece. I'll add some pages here. So for part A, we want to estimate r double prime of 8.5. R double prime is the derivative of r prime, which is the instantaneous rate of change of this. I don't have a formula, but we can say instantaneous rate of change is roughly the same as average rate of change. So we could say that r double prime of 8.5 is approximately, and let's just do the best average rate of change around 8.5. We could say r prime of 10 minus r prime of 7 over 10 minus 7. I would urge you write this rather than immediately plugging in the numbers. Communicate what you are thinking about, because if you write a number wrong, everything goes haywire. So this would be negative 3.8 minus negative 4.4 over 3. You are not required to simplify, although I believe this works out to 0.2. That's what I'm getting in my head. I'll check that against the official solutions. And what would the units be? R prime is centimeters per day, so this would be centimeters per day per day. And again, this should have been in red, sorry. So this is 0.2. But they really want to see this, and you could leave that unsimplified. Okay, let's look at part B. Is there a time t? All right, that question, I already know I'm probably thinking about the intermediate value theorem or the mean value theorem. Is there a time t between 0 and 3 at which r prime of t is equal to negative 6? So you might think, oh, they're asking about a derivative, so it's mean value theorem. But we actually have r prime already. So it's intermediate value theorem. So here's what we would notice. We would notice that negative 6 is between r prime of 0 equals negative 6.1 and r prime of 3 equals negative 5. Right, I'm communicating that intermediateness. Now, the intermediate value theorem only applies to continuous functions. Do we have enough information to conclude that r prime is continuous? So we are told that r is twice differentiable. So let's really spell that out. Don't lose points. Say what you know. So we know r is twice differentiable. So r prime is differentiable and therefore continuous. Since r prime is continuous, the intermediate value theorem applies. I've already communicated the betweenness up here. So there is a value of t in the interval from 0 to 3 with r prime of t equals negative 6. And again, when you see this question, is there a value, when they're not asking you to solve, almost certainly the answer is yes. Almost certainly you'll be using the mean value theorem or the intermediate value theorem. Okay, part C. Right, so far, we're not actually engaging with the fact that this is a cone. We're really just doing things from the table, independent of meaning. Right? Same thing's going to happen for C. So use a right Riemann sum with 4 subintervals indicated in the table to approximate that definite integral. Pretty straightforward. Right? Don't get worried about this being a derivative. Right? We have a table for r prime. Oops. Let me copy my table. We have a table for r prime, so we will do a Riemann sum for r prime. So this is approximately equal to, the first interval is 3 units wide. On the right end, the value is -5. The second interval is 4 units wide. On the right end, it's -4.4. The third interval is 3 units wide. On the right end, it's -3.8. Don't even try to process what this looks like because of the negatives. You can just follow the pattern. And the last one is 2 units wide. On the right end, the function value is -3.5. Right, and the scoring here is 2 points. Basically 1 point for something that makes it overwhelmingly clear you know what a right Riemann sum is, and then another point for getting it perfect, because maybe you miscopied something. All right, now D. So in D, we're finally dealing with the fact that this is a cone. So the height of the cone decreases at a rate of 2 centimeters per day. At time t equals 3 days, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of volume of the cone with respect to time at that time, right? And they are giving you this formula. Okay, this sounds like a related rates problem. They've already told us how V and R and H are related. Let's jump in and take derivatives. And I should have been writing in red all along. So the derivative of volume with respect to time is, I'm just going to factor out that 1/3 pi. And now we'll do product rule. Derivative of the first, there's actually a chain rule step here. That's the derivative of r squared times h plus r squared times the derivative of h. Now let's see how many specifics we have. At t equals 3, right, so I will label that that's what I'm doing. At t equals 3, the radius is 100 centimeters. dr dt is r prime, right? That's what we actually have in this table, so that is -5. The height is 50 centimeters. R squared would be 100 squared. dh dt is the rate at which the height is changing, and it is decreasing at 2 centimeters per day. So there is our expression, and there's really no need to do anything beyond this. So I am just double checking that my answer here is correct. So 2 pi over 3 times n. Okay, looks good. Yes, right. Did they ask for units or anything? Let's just double check. No, they're giving us the units, so you don't have to write them. Okay, right, and this is, hopefully a case where you know not to bother to simplify, but you check that all of your grouping symbols and parentheses are perfect. Some of you have these invisible parentheses that you put when you want to and you leave out when you don't feel like it. Everything you write must be 100% correct, because no one knows what you're thinking, they only know what you wrote. All right, I will do the last 2 problems in a different video.